So in the next problem, I believe it's question 2, we got the following graph. Now this graph is showing the position x of an object as a function of time t. So here is t, here is x. What we gotta do is determine if the velocity is either positive, negative, or 0. So we're gonna explain what the velocity is in region 1 through region 6. First off, the position of region 1 is negative because this is the center point. Up here we got the positive values, down here we got the negative values. So we can say that the rest of the region 2, 3, 4, 5, and 6 are in the positive position. Positive, 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 and positive. Next thing we're gonna do is kind of label the slopes for each of them. So for region 1, here's the slope. Region 2, here's the slope. And in between 3 and 4, the slope would be kind of like in a horizontal line. So that means the slope is 0. The slope right here. So up to this point, this is where the slope begins to become negative. So in this case it's 0. In this case it's this positive slope. Same thing here, this is positive slope. So that means that in region 1 and 2, the velocity will be positive. Velocity positive, velocity positive. Until it gets to region 5, the velocity starts to become negative. One thing we should also note is that the velocity would be the change in x divided by the change in time, or t. On the other hand, the acceleration of each region will be the change in velocity divided by the change in time. So if we look back at region 1 and 2, we say that the slope of both regions will be positive, meaning that the velocity will be positive as well. So if we give value for the velocity, let's say for this one is 4 meters per second, the small slope, and the bigger slope, let's say it's double, 8 meters per second. If we use this formula that for the acceleration, if the change in velocity we apply to region 1 and 2, we got 8 minus 4 divided by the change in time. So that's still, whatever the answer is, will be positive. So that means that the acceleration in regions 1 and 2 will be positive. So in letter A, it is stated that region 1 has a positive velocity, but the acceleration is negative. And we just proved that that's not the case, so we can discard that option. Letter B, it says region 2, the velocity is negative and the acceleration is positive. Same thing, it's not true. Then letter C, it starts saying in region 1, the position is negative. What do we say at first? In region 1, the position is negative. That is true. But it says the velocity is positive. Still, that is true. Let's keep reading. Meanwhile, in region 5, the position is positive and the velocity is positive. Okay, so let's take a look at region 5. So at first we said that the velocity will be negative in region 5. Let's put it in a better position. Right here would be the slope. Compared to this one, much bigger, we can say that this little velocity, let's call it -5, and this one could be -10. So if we do the following, the change in velocity according to a formula for acceleration, the change in velocity would be -5 minus -10. As we solve that, we get -5 plus 10. So 10 minus 5, or minus 5 plus 10, that should give us 5, which is positive. So that means that in region 5, although the velocity is negative, we got a positive acceleration. So according to letter C, region 1 is in the negative position, that is true, and it has a velocity positive, true. But then it says, meanwhile, in region 5, the position is positive, and the velocity is positive. So the position in region 5 is positive, that's true, but what's not true is that the velocity is positive. We said that the velocity was negative, so no. So we discard that option, and the last one should be the right answer. But let's read it first. In region 1, the velocity is positive, correct. The acceleration is positive, that's true. And meanwhile, in the region 5, the velocity is negative, true. And the acceleration is positive, as we just proved right here. So letter D would be the final answer.